Send money. Just a preliminary look. It looks pretty reasonable. Okay. Thanks a lot.
Welcome you to the X-43A Hyper-X post-flight news briefing from NASA's Dryden Flight Research Center at Edwards Air Force Base in California. For the past 58 years, NASA Dryden has been on the cutting edge of flight research, separating the real from the imagined problems of atmospheric flight and setting numerous aeronautical milestones in the process. Today was no exception. We have with us today 4 X-43 Hyper-X program officials who will discuss various aspects of today's milestone X-43A flight, what we achieved, and after opening comments, we'll entertain questions from media representatives here at NASA Dryden. News media representatives who are viewing this briefing on NASA television are invited to submit any questions you may have about the flight or the program via email or phone while this briefing is in progress. The email address is x43x43nov@dfrc.nasa.gov. And the call-in phone number is 661-276-3449. And we ask that you please include your name and news media affiliation in your query. For television stations that are monitoring this news conference via NASA television, B-roll video footage of highlights of today's mission will be fed following the conclusion of this briefing. On the dais to my left are Joel Sitz, the project manager, the fellow with the big smile on his face. He's project manager for X-43A flight research here at NASA Dryden. His job ended rather quickly. Next to him, Dave McAllister. You heard his voice a lot today on Mission Control, X-43A Operations Manager at NASA Dryden, Mission Controller for today's flight. Next to him is Laurie Marshall. Laurie is Dryden's Chief Engineer for the final X-43A flight today. And last but certainly not least, Randy Volan, who's a Senior Research Engineer at NASA's Langley Research Center and currently lead of the scramjet propulsion team for the X-43A. I'd like to turn it first over to Joel for opening comments, but Joel, as I seem to recall about 7 months ago, after the March flight to almost Mach 7, we had a sort of an analogy about something that you happen to have a very good interest in, to say the least. Something like a Grand Slam home run? How would you compare it with today's mission?
You're asking me for another baseball analogy?
Something like that.
Well, this is pretty close to the first time my son hit a home run when he was 12. It's got to be as good or better than the Sox breaking the curse, too. So, we had a great mission today. It's fun to be here and talk about the successful mission. This hypersonic flight's getting kind of boring. I'd say that tongue-in-cheek. It's 90 seconds of terror, but once it's over with, you realize that you really accomplished some great things. We've got a great team that helped us do that at NASA. I want to thank ATK Gassel and Boeing again for a great airplane. Tony and Lowell, thanks a lot. It worked great. And Phil Joyce and Mike, I want to thank you guys for a great rocket. Yep. Orbital Sciences, great job. I guess with that, I just want to say it's been a lot of fun over the last 6-7 years working this program. I think we've accomplished a lot. We've given industry and government, I think, a lot of confidence to go forward with hypersonic flight, hypersonic air-breathing propulsion. And I think that technology definitely has a future, and we've definitely opened that door. With that, I'll turn it over to Dave, and he can talk more about the mission specifics today.
A fantastic operation today. Had a little tough time getting going, but once we got in the control room, got settled down, things just went like clockwork. And we had fun. It is a lot of slow times in the airplane airborne and getting out to the launch condition. It takes a little while, and once we get out there, it gets real busy, it gets real exciting, and what a great day. It was fantastic. While I do have the microphone, I do want to thank our families for supporting us. My family's here, and I want to thank them for being here today and supporting me through all long weekends, long days, holidays that we had to work to get here. And I'd like to thank all the supporting crews, the mechanics, all the supporting organizations, everybody on this center just come together and helped us 110%. And that's why we are here today, is due to their hard work.
Oh, okay.
I should introduce Lori Marshall, our chief engineer. Go ahead.
Thank you. Well, I'd echo all the great things that have been said. I think we had a phenomenal flight today. Looked a lot like all of our nominal training sessions that we've done. And I think everything went really well. And like Dave said, it's really due to the team that we have. We have a magnificent team. Most of us have been together since the very beginning of this project, which was a very long time ago. And I think that's one of the reasons why we are able to be so successful, because we work really well together, and we spend a lot of time working together. And as Dave said too, a great thanks to our families who've had to make quite a lot of sacrifices. You know, when we work all those holidays, which I think on this project we've managed to work just about every single one. For Flight 3, I think Columbus Day is our only holiday off. And you know, the families have really had to sacrifice a lot there. We've just gotten used to it, I think, ourselves. So. Anyway, as far as today's flight went, I think everything going out to the launch point was pretty good, and the drop was very nominal. As I said, we had a great boost, and I think we managed to get up to about 9.6 there for separation, maybe a little bit more than that. And we went ahead and had our engine experiment. Everything looked really nominal to me, and Randy will talk about that some more, I think. And then we even went ahead and the RV recovered after the engine experiment, and we started our descent, and we actually had data from the ground-based assets longer than we had predicted. We thought we would lose data from them about 240 seconds into the mission, and we actually had data all the way through at least at the end of our Mach 7 PID, and we're about to start the Mach 6 PID maneuver, primary identification maneuver. So we got a lot of good data. We had a Navy asset in over the sea range P3 aircraft, and it actually acquired data from just prior to launch all the way to about 14 minutes after that. So based on our nominal simulations, that should have been to splash. So we'll get that data maybe tomorrow and see what we got from them. But we have quite a lot to look at for quite a long time to come. And not to belabor my comments anymore, but I do want to say that those of us sitting up here, we wouldn't be here without, like I said, the team. And I'd actually like to, because I don't think it's ever been done before, I'd actually like to acknowledge the leads of the research engineering team, and actually name them. So on behalf of myself and Robert Sherrill from NASA Langley, the chief engineer of the X-43A from Langley, and my deputy Catherine Baum here at Dryden, we'd like to thank the leads of the engineering teams, and both NASA and Dryden, and both Langley and Dryden, I should say. So starting at Langley, we have Randy Voland, who's lead propulsion engineer, and Tom Grendel, who's the lead from NASA Dryden. And in aerodynamics, we have Walt England and from Langley, and Mark Davis from Dryden. GNC, Guidance, Navigation, and Control, we have John Martin and Paul Tartarini from Langley, and Ethan Bauman from Dryden. And in structures, we have Walt Bruce from Langley and Tom Horn from Dryden. And let's see if I'm not forgetting there. In systems, flight systems, the lead there is Johan Lin, and he's from NASA Dryden. And and last but certainly not least, the man who tells us is responsible for all that data that tells us that we were successful today, our instrumentation engineer David Dowdell, and he's from NASA Dryden. So I wanted to acknowledge all those people and acknowledge them by name. Like I said, we're a really close-knit team, not just NASA, but also Orbital Sciences, ATK, and Boeing. And on most of those disciplinary teams, we've actually had representatives from each of those areas on them as well. And we've actually worked together as one team, not just NASA and industry, but actually one team. And I think that's one of the most impressive things about working on this project, and one of the things I really enjoyed the most. So without further ado, I'll give you Randy Volin, who'll talk about the thing everyone wants to hear about, which is the engine experiment. Randy?
I'll tell you a little bit about the engine experiment, but frankly, we haven't looked at the data very much because we rushed over here to the press conference. But what I can say is, it looked really, really good. I mean, in fact, it looked almost like one of our simulations that we've run recently. We run simulations of the flight over and over again to check out problems and things. And when we plot the data and look at the simulation, it looks very, very similar. So that's very good. So that's very good news. And what we've got today is really a data set that dwarfs any other data set we've ever had at these types of Mach numbers. Mach 10 is very hard to test on the ground. There's very few places you can get any data at Mach 10 with operating engines. And what we get in those ground tests is a few milliseconds of data at a time because of the type of facility required to do that. And what we've got this time is between the time the engine was open but not fueled and the time the engine was fueled, we got about 20 seconds of data. So that's dwarfs all the past Mach 10 tests combined. I mean, they only add up to, I don't know the exact number, but a second or so maybe. So this is going to be a great data set to look at, and hopefully we can go on beyond this to do some more things in this area. I don't know. It's easier than I think it's easier than people think it is. We can really do this stuff. I guess that's my message I'd like to say. And I don't mean to make it sound too easy, but it's definitely doable. And the vehicle works like we thought it would. So just one other thing, I would like to thank, Lori mentioned a lot of people, a lot of team leads, but there's a lot of people that work on these teams, and I'd really like to thank all the people that worked on this project, from Langley, Dryden, and the contractor teams. So I'll stop there.
Okay, thank you, Randy. At this time, we're going to be opening up to questions from reporters here at NASA Dryden, but before we do so, for those reporters who are viewing this briefing on NASA television or on the World Wide Web, you may also participate by sending your questions via email while the briefing is in progress. The email address is x43nov@dfrc.nasa.gov or x43nov@dfrc.nasa.gov. The call-in phone number is 661-276-3449. Those messages, either via email or phone, will be relayed into the press conference room in here and will be asked, and hopefully we'll be able to respond to those. For those reporters here at Dryden, a few ground rules. Since the news conference is being telecast on NASA television and the World Wide Web, we ask that you wait until the microphone reaches your position before asking your...
I'd like to get some of those details.
Yeah, and excuse me, as I said, I just saw basically the real-time data on the displays. We were starting to do the data playbacks so we could re-look at some of this stuff when I had to come down here. So what I can tell you is we reached, the engine test occurred at slightly under Mach 10, but it's, in the realm of where we thought we'd be. We thought we'd be slightly below Mach 10. Let's see, that was about 10 seconds of fuel on time, 20 seconds total with the engine open and air flowing through the engine. We do a post-fuel tear, we call it, where we don't run fuel, so we get the engine forces, the vehicle forces in moments with just the engine open, and then we turn the fuel on, and we have several fuel levels that we run to get the forces and moments and how the vehicle behaves under different throttle settings, basically. So the total time the engine test was 20 seconds. The fuel time was about 10 seconds.
So another world record?
Yeah, I believe so. I think.
Okay, I saw a hand over here, and I believe Mike Dornheim was second up.
Mike Dornheim with Aviation Week. Were you expecting thrust greater than drag in